Alrighty, let's try this again. I'm Allison Hahn, Program Manager for Advanced Methods for Manufacturing. Before I go into this presentation any further, I just want to make it clear I'm going to be touching on two separate work scopes today, the NEET 1 work scope, which is the AMM R&D only portion, and then also NSUF 1.2C, which is AMM R&D plus NSUF access. So the AMM program was initiated in FY 2012 under the overarching cross-cutting technology development program with the purpose of improving the method by which nuclear components and plants are manufactured, fabricated, and assembled with the purpose of building these plants faster, cheaper, and with more reliability. The way to do this, one portion of it is to bring in other practices found in industries that also produce large components. So the first technical work scope area, which again is NEET 1, the AMM R&D only portion, nothing much has changed this year. We have two areas narrowed down, factory and field fabrication techniques and the advances in manufacturing processes for components. I have two slides that's going to go into more detail on each of these. So to begin, factory and field fabrication techniques. We're looking at improvements in welding to improve the speed and quality, new joining technologies, surface modification techniques specifically to address corrosion issues, and then overall improvements in shop floor applications in the factory. So we're not really giving any direction on either of these two work scopes, so leave it open to the PI to give us your ideas on that part. The second portion, manufacturing processes, we're looking for reactor internals, fuel cladding, fuel support assemblies, vessels, pressure boundary components. One thing we are not looking for is fuel, actual fuel. We do not manufacture fuel under the AMM program. But everything else on here we are interested in, improvements in the conventional manufacturing processes, and then, of course, again, corrosion and wear-resistant applications. So switching focus, we're going on to NSUF 1.2C, advances in innovating manufacturing techniques ready for irradiation testing. I want to make it clear here that this is the next step from the AMM NEET 1 R&D only work scope. This is for practices and processes that have already been developed. The R&D has already been put into it, and the process is well known. An example, NSUF is looking for these components to be developed and fabricated within 5 months of project initiation. So this is that next step from the NEET 1 work scope. Some examples in this one, we're looking for joining techniques for silicon carbide cladding components, and then also coupling to some of the modeling mechanisms that we have available. Again, just to make clear, 5 months after project initiation, we expect these components to be developed and fabricated already, so process is known. And then there is a 3-year, $750,000 limit on the PIE portion of that. So irradiation up to 3 years, $750,000 for the PIE after it's been irradiated. So this next few slides has a list of projects that AMM has already awarded. The 11, 12, and 13 projects have already been completed. The final reports are available or will be shortly available on the OSTI website, so I suggest you look at those final reports to see what was done in these awards. More specifically, for those awards that we award under the NEET 1 R&D only work scope, next steps, again, theme here is the next steps. What are we looking for? Some of the projects that have already been completed, what else needs to be done to get them into industry, to get them to commercialization? So what other work needs to be done on some of these projects? So definitely take a look at those awards. We also have the annual award summaries, which is a one-pager on all of the projects. That is available on the NEET website. We also have our newsletters, which is a semi-annual issue on a handful of projects. Those are a couple pages, updates, more consistent updates for our projects. So also look to those two documents. So in 2014, this is the first set of active projects that we have. We're looking at periodic material-based seismic isolators. We have the combination of accident thermal conditions on the seismic performance, that's out of Purdue, and then also an optical closed-looped weld monitoring system out of Oak Ridge National Lab. That's the first set of active projects. 2015, we funded GE for some additive manufacturing work. INL on-site fabrication of large-scale components. Texas A&M surface plasma nitriding, you saw a picture of that earlier in the presentation. And then prefabricated rebar systems out of the University of Notre Dame. 2016, so I wanted to take a moment on these awards. Something that's a little bit different in the 2016 was the first year that we awarded the top two are AMM only R&D projects. So this is a good example. We had made a previous award on the laser powder bed method. This first project out of EPRI is looking at a qualification process and a monitoring process. So that's that next step. Once they've developed that process, what else needs to be done? We need to qualify these components. So that's looking at that. We're also looking at friction stir additive manufacturing out of Oak Ridge National Lab. And then the bottom two are R&D in combination with the NSUF access. So these two projects both happen to be doing irradiation testing, both on additive manufacturing techniques. But the two techniques that each of these schools are looking at are developed, are well known. There's a high confidence that they can have those components fabricated for the start of the project. So I just wanted to note that difference in these projects awarded that year. So in summary, decrease the costs, decrease the schedule, increase the reliability to get these new plants built. What do we need for some of the projects that already have been awarded or some other technologies, techniques that you have been working on outside of this previous year's solicitation to gain acceptance for those codes and standards bodies? What else is next? Specifically to get these technologies deployed and out into the nuclear industry. So that's something that we're really focused on. So make sure you point that out in your application. And then contact information. Again, my name is Allison Hahn, Program Manager for the Advanced Methods for Manufacturing program. Listed here is Jack Lance, our technical lead. Both our emails are available. If you have specific questions related to your specific scope, you can email us, or I can also take questions that are for the good of the group right now.
Are there any components of specific interest?
No, we don't have anything specific. One thing that is called out are the silicon carbide end caps. That's listed under the NSUF 1.2C, but otherwise we're leaving it open to hear what you think.
Allison, would field-assisted sintering be of interest?
Yes. Yes, it would.
Is there a target TRL?
No. Obviously, the upper TRL levels, if it's specific to a particular component in terms of a reactor design, that's not something that we're looking for. We look to include technologies and techniques for a broad array of nuclear reactors, so more in that median range, but we don't have a specific TRL level range that we're looking for.
What type of components are you interested in for field-assisted sintering?
That one I would have to get back to you on in terms of specifics. I'm not clear on that, but I can certainly get back to you if you'd like to email me at the email address listed on the screen here.
Do you fund advanced manufacturing of reactor components with embedded sensors?
We do. We also have the Advanced Sensors and Instrumentation program, so it depends on what work specifically needs to be done. Are these sensors and instrumentation already developed and you're trying to put it into the components in terms of manufacturing the components, or are you doing development work on advanced sensors and instrumentation? So it depends where along the product development line that would be.
Would graphite manufacturing be a target application?
I believe so. That gets a little specific into the reactor design, so if you can make the case that it's applicable to a few different reactor designs, then yes.
Are cements a topic of interest?
So AMM funded a few concrete proposals in the past few years. I believe it's 2013. We have a few, so that's not a high program priority at the moment, but we do typically, we have funded concrete proposals in the past.
Does irradiation testing need to be done with neutrons, or would heavy ions also be applicable?
Both. However, we offer neutron and ion irradiation. The full suite of partner capabilities is available at the NSUF website. believe it's nsuf.inl.gov. All of the partner facilities listed on there, and then exactly which capabilities are offered at those facilities as well.
Are ceramic metal composites of interest?
That I would have to look into a little bit more. I'm not materials expert, so I would have to consult with that. Again, if you email me at the email address, I can get back to you more specifically.
Friction stir additive manufacturing has been funded in 2016. Are there more opportunities this year on that topic?
There's certainly not opportunities. You have to make the case that it is different than what we have already funded. The abstract is already online. I can contact you directly if you need more information, but we do not fund multiple techniques if they're duplicative of each other. If it builds upon something, you have to show that it's different than what we currently fund.
Is an industry partner required for NEET 1?
An industry partner is not required. NEET 1 is open to industry labs and universities to actually lead the project. We obviously, collaboration is encouraged, and we would like it, but it's not required.
Is the program targeted more toward innovative manufacturing techniques or new material development / manufacturing?
Innovative manufacturing techniques.
Is additive manufacturing of ceramics also of interest, or is it only metals?
It's not necessarily only metals, but again, you have to make the case that it's applicable to a few different variety of reactor types. I think ceramics would be okay, though.
How many awards do you anticipate awarding in the area?
I believe we're looking at approximately 2 awards this year, but that's all dependent upon our budget situation.
How many pre-proposals did you get last year?
I'd have to look that one up. I think we got about 10, 15 maybe. Off the top of my head, I'd have to confirm that number, though.